This is the screencast for section 1.5, parametric relations and inverses. Example 1 is defining a function parametrically. Now, parametric functions have kind of three variables. X is dependent on what's happening with t, and y is dependent on what's happening with t, and then there is an xy pair after that to show their relationship. In part A, find the points determined by t equals -3, -2, etc. So all you have to do is plug in those values. So for example, t equals -3. I'm going to plug in -3 for t, which gives me my x value and my y value. I could do that for all of these, but I mean, you get the idea. It's plugging in the t value, and then out comes an x and a y value. Let's see. I'm also going to jump ahead to part C. I'm going to graph the relation in the xy plane first because I can get these values also from the table. To graph a parametric function, you have to go to Mode on your calculator, arrow down to where it says Func, and we're going to go over to parametric. So we're getting out of function mode, going into parametric mode. Now as you go to y equals, you see that you have the opportunity to do an x equation and a y equation. So then x in this case is t, which is still your x key, plus 1. And then y is t squared plus 2t. And now I can graph that. I'm going to zoom 6 so I can see that a little bit better. It looks like maybe a parabola. I don't know, kind of hard to tell exactly what's going on there, but part B is going to help us out. Part B says find an algebraic relationship. Oh wait, I said we could see the table values. Go to second table. See when t equals values x1 and y1 are available, their values are also available. My table's all messed up. Yours might be too. Go to second table set, which is the window key. So I'm going to start my table at -3. And now my table, the change in each table is 1. So I'm going to go from -3 to -2, -2 to -1, -1 to 0, etc. So now second table will show me all of those values, the x, y values, when for certain values of t. Now part B says find an algebraic relationship between x and y. This is often called eliminating the parameter. So t is your parameter, the variable that both x and y are dependent on. So we're going to eliminate that using what we learned in the last section, 1.4, composition functions. X equals t plus 1 and y is t squared plus 2t. So the thing relating both x and y is t. So I'm going to find out what t equals in terms of x. So if x equals t plus 1, that means t equals x minus 1. Now I can plug in x minus 1 for each value of t in y. So y equals not t anymore, but x minus 1 squared plus 2, again not t, but x minus 1. So I can see that I do have a parabolic equation. I can expand that out. So now that we know what this graph is supposed to look like, y equals x squared minus 1, it brings us back to part C. I mean, we're supposed to finish this parabola, so there's more on my calculator that I need to do. Go to Window. You have to set your Tmin and Tmax. In this case, my Tmin can be -3, and my Tmax can be +3, and I'll have my T-step be +1. Now I can see the portion of the graph that part A has asked me to find, where t equals -3, -2, -1, 0, 1, 2, and 3, etc. If I want to see even more, then I can go to my window and set my Tmin even further. The now try problem for example 1 is number 5, and it asks us to do the same thing. Find the points determined by plugging in -3, -2, -1, 0, 1, 2, and 3 into these parameters. So I have x equals 2 times, or these equations, 2 times the t-value -3, which would be -6. Y equals then 3 times that specific t-value, -3, -1, which would be -9 minus 1, so -10. So the point created when t equals -3 is -6, -10. Again, I can find these using my calculator. My x equation is 2t. My y equation is 3t minus 1. Oh, that didn't work out really well. 3t minus 1. And I'm going to set my table, well, actually I have it set the same way because I'm looking for the same t values. Part B asks us to find a direct algebraic relationship between x and y and determine whether the parametric equations determine y as a function of x. Well, again, the thing relating x and y is that t value. So I'm going to, for part B, take x equals 2t, and I'm going to solve for t. So t is x over 2. Now I can plug that in to the y equation. So instead of using t, I'm going to use x over 2 minus 1. So y equals 3/2 x minus 1, which is linear, so this is a function. Part C, graph the relationship in the xy plane. So at this point I have them typed in, I believe. Yep, so I can just hit graph. And there's the line that I predicted. 3/2 x minus 1, so a slope of 3/2, a y-intercept of -1.